Okay, so welcome back. This is part 3 in our series where we're showing you how to develop this very inexpensive and awesome aircraft flight tracking system that can track aircraft in your area. And again, it's very inexpensive. It's what you see here. We've got an antenna. It comes with a tripod and some coaxial cable and this USB dongle, which is like a USB thumb drive that plugs into your computer. And what it does is it allows you to receive information from aircraft in your area and take those signals through the antenna and convert them to usable data. And in the last video in this series, we showed you how to install a awesome piece of software on your Windows computer like this laptop you see here. And what that does is it takes the data coming out of that USB dongle and converts it to useful information about all of the aircraft being tracked in your area. And we also talked in another series about developing in C# this application here, which does something similar, but instead of from a local antenna and what's called a SDR or software-defined radio, it grabs data from a free web server, and that web server sends information about all the flights it has been tracking in your area. And we showed you how to write a software application that took all that raw data and actually map those aircraft onto the satellite image. So in the previous video, we showed you how to install this application on your Windows computer. Here we've got a laptop, and we installed this application called Dump 1090, and that allowed you to take the data coming out of this USB dongle and convert it to what you see here, which is a console output of the data associated with the tracked flights in your area. And as you can see, it's got some specific information coming from this Dump 1090. It's got a flight number, the altitude, the speed, the heading, latitude and longitude that you can use to locate the flight. Also signal strength, number of messages that have been received from that flight. And also on the end, it has this TI, which means how many seconds have passed since the last message was received. And all of this is nice. It's got some good information. However, you may want to customize the information and, as an example, put it into your application. You see here the C# application that you can track the flights. But also you can do a lot of other stuff. You can get other information about the flights. And you could also do something like you see here. And what I've done is I've taken information from the antenna and the SDR, the dongle, from Dump 1090 as it grabs the data. And over multiple hours, I have kept track of the furthest away flights that have been detected. And I've made what's called a radar chart. This is in Excel. And for each 10 degrees, I've kept track of what's the furthest distance that any flight has been detected from our local antenna, and I have charted it here. And you can see in this blue, I've got for each 10-degree increment, I'm starting out at 20 miles, 40 miles, 60 miles, and you can see at this particular angle, around 300 degrees to 310 degrees, I can get flights that are up to 180 miles away with the very simple antenna and SDR dongle. So it's really useful to find out how effective your antenna is and so on. You can also use that data for other things. For example, for adding to this web server information. If you can get some additional flights locally, you can add them to your display. So you can do a lot of things. And what we're going to do in this video is we're going to say, okay, now that we've got Dump 1090 installed and it is giving us data, we also know that it has the ability to not only show you the data in this console display, but also to send all that data over Wi-Fi or Ethernet to another computer using TCP. And what we can do with that other computer is do the processing of that data like we showed, maybe have a radar chart, or add it to this other application that's grabbing from the web server, or we can do whatever we want. So we're going to start to look at the details of what does this dump 1090 do aside from the console? What is the data that it allows you to send over TCP and grab so that we can start working on our main computer, figure out how we can grab the data from dump 1090. So in the last video, we showed you how to download dump 1090 from this GitHub website, Malcolm Robb, dump 1090. And the documentation here explains about some of the features of dump 1090. And what we'll do is we'll scroll down and you can see where it's got network server features. And this tells us about how we can connect to dump 1090 on our remote Windows computer, and we can grab the data that it is sending out to the console. So there are different ports that you can access. If you access port 30002, it will give you the raw data that represents each of these packets of data coming from the antenna on 1090 megahertz. 30,002 is for raw data. Port 30,001 is if you want to send data, you can send it to that port and send it out to the antenna. In our case, we're going to access port 30,003. And it says connected clients are served with messages in SBS1 or base station format that look like this. And you can see it's got message and it's got some data. So let's take a look at what this is and how we can process it and parse it and use it. So if we take a look, the first thing we might notice is there's a bunch of data, but they're all separated by commas. So that tells us, okay, each line is a CSV line of data, comma separated values. So we can parse it, as we've done many times in this channel, using CSV parsing. Also, each message packet may contain multiple messages or lines. So for example, these two lines represent one packet of data that was received. When we query with TCP, it might send back these two lines. So we have to make sure that we know that each time we ask for something, it might contain multiple lines which we're going to have to parse. So we know it's CSV data. We know it might be multiple lines that we're going to have to parse. Also, each line has 22 values. So there are 22 CSV or comma separated values in each line. So that's going to be really important because, of course, this is coming over radio and it's going to be highly likely that we might get some bad data. So the more we can be assured of, the more we can have some really good clean parsing. If we know that each legitimate line has 22 values, we can say, hey, if we parse all these CSVs and it doesn't have 22 values, it's probably a bad message and we can delete it. So keep that in mind, 22 values. Also, it's very important that you understand that each line does not contain all the info about a flight. So if you look here, this is actual data received. It's got a message number and it's got some stuff. And here it's got, oh, that's a year, month, and day. Well, that looks like a time. And there's another year, month, and day with a time. And here we've got a bunch of nothing. But here we've got a value in this other message. So here there's nothing. Here's a value. Maybe that's an altitude, 23,600, right? And then here's another message. It's got, hey, that's got a 23,600, but it's also got these other values. And if you think about it, that could be latitude and longitude. So the different message, there are different message types, and the different message types can have different data associated with them. So it can get kind of complicated. You're going to have to not only parse each packet to make sure you've got the multiple lines, you're going to have to make sure you've got 22 CSV values, but also the different lines, the different message types can have different data. And you can see here we've got a message, and the next value is a number, like a message class 8 and a message class 7. Maybe a message class 7 has an altitude where message class 8 doesn't, and a message class 3 has an altitude, latitude, and longitude, and so on. So we're going to have to, put in some effort to say, okay, I've got a received line of data. We're going to have to know how to access that and parse it and add it to whatever other data we have on that unique flight. So we're going to have to say, okay, what's the unique flight number? What's the message type? And what data should it have? And if it's got that data, I can add it to that unique message type. So we're going to have to keep all those things in mind when we start parsing this. So different message types provide different information, and you're going to have to keep track of what message type you've got. You might get a message with only call sign, then 30 seconds later, another message for the same aircraft containing latitude and longitude. You're going to have to know what message type has what data, and then grab that associated data for each message. Now, there are some good websites that explain what all this data is. There's one called woodair.net that explains in very good detail what all the message formats are. So here is the woodair.net/SBS/article/barebones42 socket data. And really nice, it tells you exactly what we were talking about. Here's the raw data sent by the SBS unit using a telnet. We don't have to worry about that, but it's port 30,003. And here's a data stream and explains there's different message types and different message values. And you can go through all this and look, there's 1, 2, 3, 4, 5, 6 message types. We were looking at the MSG, which is a transmission message generated by the aircraft. And there are subtypes of the message. There are 8 different MSG types, but there's also a click message, a status, a new aircraft, and so on. So as we saw before, the message types can have a 1, which is an ID and category, a 2, which is a surface position message, 3, airborne position message, and so on. So we're going to have to be knowledgeable about all of these types and parse them appropriately. Then we've got field data. And you can see we've got 22 values, and these describe all of the data that can appear in each line, but as we saw, aren't necessarily going to be appearing depending on the message type. So we've got the message type, MSG, transmission type, that's the value 1 to 8, session ID, aircraft ID, hex identification, which is a unique hexadecimal format, flight ID, which is like a call sign, date message generated. As we saw before, there's a date and then there's a comma time. So there's date message generated, time message generated. And then there is another date message logged and time message logged. And then we get down to the data. So fields 11 through 22 give us the actual data. And again, these aren't always going to appear in each message. So there's the call sign, the altitude, the ground speed, the track or heading, the latitude, longitude, vertical rate, squawk, and then some alerts, emergency, SPI, and is on ground. So there are some Boolean flags. These last 4 are Boolean flags. And then the rest here is the important stuff we're going to want. Call sign, track, latitude, and longitude are the most important for us if we're going to be mapping those to a satellite image. So really wonderful stuff, and you can dig down into this to see what each message has, and there's a lot of other information. Now, there is also a wonderful website at web.stanford.edu, which is Stanford University, /class/EE179/labs, lab 7, and it talks in detail about the ADS-B, Automatic Dependent Surveillance Broadcast signals, and how they work. Really wonderful information. We've got the 1090 megahertz data sent from the aircraft, and you see some examples. And you also talk about this USB dongle, and here it talks about how you can decode the ADS-B packets. And here it shows the actual details about the digital packets that represent each of the messages. and you can go into this and you can, they're talking about doing it in MATLAB, but you can look at the actual signals and how what they do is they convert these waveforms into data bits, and then they get a threshold to get a square wave, and this is actual data bits that you can get from the signal. So you can go through this and get a lot of detail about what's actually going on, but at least we have a good indication of how we're going to have to grab those messages that look like this coming from the dongle, and we're going to have to parse them. We're going to have to, most importantly, make sure that the data is correct. We're going to have to do a lot of error checking on this data to make sure we don't have bad messages. And then once we have all that figured out, we can say, okay, value number 7 is a date and 8 is a time and so on. Then we can parse them. And as you can imagine, for example, we know the date and time that the message was logged. That will help us figure out how many seconds since the last message was received, to see if, we haven't received a message in a couple minutes. That means it's probably out of range. We can use this data for determining how far away it is from our location by using latitude and longitude. We can also figure out the angle or the bearing from our location to that flight by calculating from the latitude and longitude. So we can do a whole lot with this data, but the big thing is going to be how we're going to parse it and how we're going to put that into software so that we can process it. So in the next video, we're going to start to see how we can develop this simple C# application, which arguably is the easiest part of all this because we've already done all the legwork, figured out what we need to do, and now it's just a matter of parsing the data and displaying it however we want. So you can see our C# application is basically over TCP, over Wi-Fi. It is grabbing the data from our dump 1090 application on our remote computer connected to the antenna and the SDR, and it is grabbing this data in a fraction of a second, and it's displaying it. It is doing some calculations. For example, it's calculating distance between the SDR location and the aircraft, the bearing, what is the angle between the SDR and the aircraft, the heading, altitude, latitude, and longitude, last message, how long ago was the last message received. You can see this is almost a minute, so now after 60 seconds we're going to close it down. So we're doing a lot of stuff here, and we are also calculating, for example, the maximum distance that has been detected so far, and we are also saving for each 10-degree increment what is the furthest aircraft that's been detected so we can map it. So you can do a whole lot with this simple C# application. So in the next video, we're going to look at some of the simple logic we can use to do the parsing and calculating some of the geographic values that we need to obtain. So if you're liking these videos, I encourage you to hit the like button, subscribe, hit the bell notifications, but most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.